時間です。では始めましょう。私のセッションに来てくれてありがとうございます。全部日本語でしませんけどこのオープニングちょっと話します。はい、このセッションはマルティクラスターマジックス、Argo CD とクラスターインベントリと、This is Multicluster Magics with Argo CD and Cluster Inventory. Oh, I thought I put my Japanese introduction here, but I didn't. But hello, everyone. I'm Kaslin Fields, and I am a manager of developer relations engineering at Google Cloud, where my team focuses on cloud runtimes, which is GKE, and Cloud Run, which is our serverless offering. I'm also an ambassador of the Cloud Native Computing Foundation, a co-chair of the Special Interest Group for Contributor Experience in Open Source Kubernetes, and a co-host of the Kubernetes podcast from Google, if you've ever heard that before. It is an audio podcast. Let's get started. Today, we'll be diving into the ever-interesting world of multi-cluster management, focusing on how CD tools like Argo, along with newer standardized concepts like cluster inventory, can make your multi-cluster operations truly magical. Mahou mitai. We'll cover the story in 3 parts. Part 1, you'll get a bit of Kubernetes history, which is my favorite thing to teach. And then we'll explore a multi-cluster use case and what makes it tricky. Then we'll talk about how to solve the challenges with standards. Let's start with part 1, a tale as old as Kubernetes. Since the beginning, users have wanted to deploy and manage workloads across clusters. I call this Kubernetes for Kubernetes, meaning Kubernetes that manages apps being managed by Kubernetes that manages clusters. Because often when people describe it, that's kind of what they want. The way that Kubernetes manages apps, they wish they could do with clusters. A big problem that has kept folks from actually doing this is that Kubernetes clusters don't know anything about themselves, much less anything else. To manage workloads across multiple clusters, you need some way to know which cluster is which, but within a cluster, it has no way to refer to itself or other clusters. So there's no cluster name, there's no cluster ID. This is a big thing that's stood in the way of implementing some kind of Kubernetes for cluster management. The community's first attempt to solve this problem is now a well-known and often used feature: namespaces. Remember, Kubernetes was born in an era when containers were clearly taking over as the way to package, isolate, and distribute applications. Before containers, people used virtual machines to do this. Containers made packaging, isolation, and distribution of applications easier. But virtualization still had its benefits. It was and still is a very useful concept. Namespaces ask the question, if a cluster knows nothing about itself or other clusters, why not just partition it up, just like virtual machines? Except, instead of actual compute resources, namespaces partition up Kubernetes objects like deployments and services. This works well as a way to logically organize your cluster and kind of manage what's on it, and it's generally considered a best practice to use them. But namespaces don't actually solve a lot of the problems that cause users to run multiple clusters. Problems like latency or data gravity considerations that require clusters to be located in different geographic regions. Or isolation needs, where users want to manage the security boundary of their workloads and their clusters as the cluster boundary. So namespaces don't really solve a lot of the multi-cluster problems, so it's still a thing that people want. To solve it, we're going to need to get more specific in understanding exactly what a multi-cluster use case is and what it needs. Let's look at a use case, shall we? Let's talk about a scenario that plays out pretty commonly. Let's say you have multiple clusters and you want to deploy a given application across these clusters. Of all the things you can do in Kubernetes, deploying an application is pretty easy. Making sure it's deployed across the clusters is the challenging part. How are you going to do that? What do you need? You need to know which clusters you want to deploy to, right? This seems very automatable. Take the application and the list of clusters and trigger a deploy operation on all of them. Argo is a tool for continuous delivery. So imagine a scenario where you're developing the application that needs to run in multiple environments. Those environments are independent Kubernetes clusters. Automating deployment to all those target clusters makes sense as part of your continuous deployment or continuous delivery pipeline. As a CD tool, Argo has a concept for this. They keep cluster lists in secrets. That also makes sense. To achieve this goal, you need a list, and you don't want everybody knowing where your clusters are, how to get into them, so storing it as a secret makes sense. Also, a bonus challenge in this use case. Sure, you can deploy to each cluster pretty easily as long as you know where you're deploying to. But remember that namespace concept that we just talked about? As a best practice, it's a good idea to use those to organize your cluster. So deploying that workload on its own namespace might be a good idea. In multi-cluster, there's a concept of namespace sameness, which means that in each of those clusters you want to deploy to, you're going to have the same namespace that you're going to deploy that workload into. That way you know not just what clusters you want to deploy on, but also where on those clusters you're going to deploy. However, consider the scenario where there's more than one application that needs to go to multiple clusters across the company. For one thing, you probably need another namespace to keep those two workloads separate. And maybe one organization has 5 clusters, but another organization has 3, and you need to deploy this application to organization 1, and this application to organization 2. So you might not have to deploy to all of your clusters at the same time. You might need separate groupings for different types of applications. So now you have multiple cluster lists. How do you manage your lists of clusters? Now you need another tool to manage the lists of clusters. Is that a list of cluster lists? This is starting to feel recursive. But it is a thing, and Argo CD in this scenario becomes a consumer of these various cluster lists, making it kind of a cluster manager in a general sense. And the complexity of an already complex system grows. And Argo isn't the only tool doing this. Consider the landscape. There are numerous open source projects focusing on multi-cluster management, like KubeFleet, Open Cluster Management, and Karmada. Then there are open source projects with a multi-cluster mode, such as Q and Argo CD. Even cloud providers like GKE Fleet and Azure Kubernetes Fleet Manager are trying to help users run multiple clusters. Each of these solutions brings its own way of managing cluster lists, contributing to the fragmentation. The core issue that we've seen is that every cluster manager keeps inventing the same thing over and over again. There's a constant cycle of recreating cluster lists and managers. And what do you think is going to happen if you want to use more than one of those tools that we just mentioned? Things get even more messy. This situation brings to mind a classic XKCD comic. There are so many competing ways to just handle a list of Kubernetes clusters. There simply must be a better way. We need to move beyond continually inventing new lists and find a more unified approach. So let's talk about standards. There are a lot of projects trying to enable users to run and manage multiple Kubernetes clusters. If we want a solid standard on how to do it, we need it to come from a reputable source. The magicians creating this magical multi-cluster standard are the contributors to SIG-Multicluster in open source Kubernetes. SIG-Multicluster has created not one, but 2 API standards that contribute to the solution we need. Let's talk about them. First, in 2020, SIG-Multicluster created an API standard called the Multi-Cluster Services API. This API defines a standard way to interact with services across multiple clusters. It aims to make accessing services across all of those clusters as straightforward as it would be if you were accessing a service on just a single cluster. It defines 3 key objects: service export, which talks about how you take a service from one machine or one cluster and export it; service import, which is how you take those services into a new cluster; and cluster set, which is a concept for working with a group of clusters as a single unit. MCS, or multi-cluster services, defines a way to manage services across clusters, but we still have the problem that clusters don't know about themselves or others. So the cluster set is a little difficult to manage. So MCS alone does not multi-cluster magic make. We can now manage workloads across clusters, but we still need a way to manage the clusters themselves. To address this problem, SIG-Multicluster created another API, the Cluster Profiles API. This offers a standardized way to describe a Kubernetes cluster within a multi-cluster environment. It defines the cluster profile resource, which is a custom resource definition within Kubernetes, and it contains details like the cluster's properties and status. Cluster profiles give us a way to understand the finer details of the infrastructure available in our multi-cluster environment. Each cluster profile object can define the unique characteristics of a cluster. For example, does this cluster have GPUs? Here's an example of how you define a cluster profile resource on a Kubernetes cluster. You can tell it what namespace it's going to deploy stuff to and give it properties that are ultimately going to help you centrally manage applications across different kinds of clusters. Did everybody get that picture? Do you need it? 写真を撮った? Combined with the cluster set concept from the Multi-Cluster Services API, this means that we can define groupings of clusters that describe where we can deploy workloads. A cluster inventory is a concept that describes a collection of these cluster sets. So now we have a standard for how we define clusters via cluster profiles, group them into cluster sets, and manage groupings within our cluster inventory. But how do we put it all together? What's managing all of these clusters? Here's an example of how Google is casting these multi-cluster magics that we just learned about. We have an open source implementation of SIG-Multicluster's standard APIs, which is what they're meant for. Creating an API standard is about making sure that vendors are implementing those standards so that people can use them with whatever environment that they're using. So this is just one example. So this multi-cluster orchestrator is our version of implementing those standards that we just talked about. Its goal is to make sure that folks within Google Cloud can run multiple clusters and manage them using these resources. And it does several things. First, it defines a hub cluster, which is a cluster that manages all your other Kubernetes clusters. We define the cluster profile as a custom resource definition, so it needs to exist within a Kubernetes cluster. Very Kubernetes for Kubernetes. And because this is an implementation of those open standards, it allows Google's users to do things that are more specific to Google's infrastructure. For example, it implements Google-specific smarts for bin packing based on user-defined policies. And it knows how to identify and utilize open capacity. So here's a look at the hub cluster concept. This is one implementation of that manager cluster for your multiple clusters. The MCS and cluster profile APIs are implemented as Kubernetes custom resource definitions. So those custom resource definitions are running on this hub cluster. Officially, it is the cluster where multi-cluster controllers run. It serves as a central point for monitoring, workload distribution, and central configuration of global objects across all of your clusters, making it the administrative heart of a multi-cluster environment. Visualizing this, We have a hub cluster, which holds multiple cluster profile objects, and these cluster profile objects can represent all kinds of clusters from sources that support the cluster profile custom resource definition, like GKE and AKS. This hub cluster becomes the source of truth for cluster profile consumers, like MultiQ and Argo, which have components running on that hub cluster as well. These consumers use the cluster profiles, often grouped into cluster sets, to deploy across clusters. They're consumers of your cluster inventory, not just a single list. This standardized approach aims to simplify how applications, users, and tools interact with various clusters. Let's look at a more complete architectural view of a multi-cluster architecture built with our MCO example. Let's say an internal client wants to run something on multiple clusters. They create their workload and then send it to be run. Behind the scenes, the control plane, acting as a hub cluster, knows which clusters to send the workload to. It connects the workload with a multi-cluster gateway, which is a networking gateway that manages the connections to all those other clusters. And it manages the scheduling on those clusters, adjusting them over time, just like a Kubernetes cluster would for its own resources, except across multiple clusters. So coming back to our problem and solution, even though Kubernetes clusters don't know anything about themselves or the world outside, the Multi-Cluster Services API teaches Kubernetes about clusters using a custom resource definition. Those cluster profile objects can be used by a variety of tools to centralize and unify the way they interact with multiple clusters, almost like magic. And the multi-cluster services and cluster profiles APIs are open source definitions, which means you could contribute to them and help make those standards better. To learn more and get involved, please visit SIG-Multicluster, and the website link is up here. You can also join us on Slack in the SIG-Multicluster channel on the Kubernetes Slack, or if you're more interested in the Argo CD side of how it takes in these things, you can join Argo CD in the CNCF Slack. Additionally, you can explore the Multi-Cluster Orchestrator project on GitHub. We encourage you to join the conversation and contribute to these exciting advancements in multi-cluster management. Thank you very much for coming today, and I can take questions now.
Thank you so much for your awesome presentation. And I remember your public podcast, the latest podcast episode is about this multi-cluster auto-scale orchestration. And I have a question about the auto-scaling because at the episode, they discussed about the auto-scaling in the cluster, hub cluster, maybe.
Yes.
So can you elaborate on that, about the auto-scaling?
Like auto-scaling the number of clusters in your multi-cluster environment?
Yes, yeah.
Right. So one thing that I should point out is that the cluster resource definitions, the custom resource definitions, often a custom resource definition in Kubernetes defines how to create and destroy things, but the Kubernetes clusters still don't actually know anything about other clusters outside of themselves. So the Kubernetes cluster itself is not going to be doing the creation and management of, well, it'll do some management of the workloads on those clusters, but not the creation of the clusters themselves. So you still need external tooling to do that.
I see. So this is auto-scaling of the workload is not the scope of this project? And, okay.
Correct.
Thank you.
Thank you for the presentation. And my question is about probably SIG-Multicluster question. Cluster inventory and multi-cluster service will be very great. However, from the user perspective, more upper-level standard API would be useful. For example, multi-cluster deployment or something. Is there any plan for standardize such a thing?
I think that the way that the multi-cluster SIG has been approaching this is very like piece by piece. So that's kind of what we see here with the multi-cluster services API, and especially with namespaces. They took a few of the problems with multi-cluster and they implemented namespaces, and then they took a few more and implemented the multi-cluster services API. So they're kind of incrementally building up the features that you need, I think, for something like that. So I don't know if they're planning to create one API to rule them all. But I think they're building the pieces of it, so I would talk with them about that.
Okay, thank you. So there are so many cluster manager OSS, so I'm not sure which is the best or something.
Yeah, and that's another consideration for SIG-Multicluster, is being based within open source Kubernetes. They do kind of try to keep within Kubernetes scope, and there's all these additional tools like Argo CD and the other ones that I mentioned earlier, which there are many of. And so they all need different aspects of the multi-cluster problem. So they want to make something that's extensible so that those tools can build on what they have. So they probably won't replace what those tools do, but they'll make something that those tools can implement, kind of like these.
Thank you very much.
Yeah. There's a question down here. There's a mic. Oh, we'll make it to you next.
Oh, for me first?
Yes.
Yeah?
Yes, please.
Thank you. This is definitely a problem we have. The standardizing things like the MCS are great, but all of the implementations coming out are very vendor specific. So you get a standard API, but the use of them is very on your cloud. Do you see open source implementation? Hello? Do you see
I can repeat. I think I can hear you.
Do you see open source implementations of things like the MCS implementation and how you synchronize across clusters coming out, or you think this will always be a vendor-specific space?
So the question is, do you see there being more centralized versions of multi-cluster APIs rather than these very vendor-specific ones? I think the vendor-specific nature of these is a choice because of exactly what we were talking about with like the auto-scaling of the clusters. You can't do that unless you know what environment you're working within. And thus, it makes sense for the vendors to implement them. And so that's why they went with the, here's an API standard, vendors please implement this route. But it can be quite frustrating for users who have multiple different vendors, though the idea is for the standard to be a unified way that you interact with all of those different vendors. But thus far, this concept is relatively early in its adoption. I think there have been some inconsistencies with how vendors actually implement the standards. So I think the solution there might be stronger standards. Do you have the mic? Oh, yes.
Thank you. Thank you. I just want to hear about the use case or successful case using multiple clusters. I'd like to know about why we need to use a multi-cluster for high availability or cutting the latency or something like that. About the use case.
A very interesting use case comes to mind for me, an internal use case where there's a team that is doing testing, and for their testing purposes, they use a whole node of a Kubernetes cluster to represent a different piece of hardware. Okay. And so they do a pod per node. So you can imagine that those clusters get very large very quickly. So because of how large those clusters are, they may choose to do separate clusters for different teams, since what they're trying to do is interesting hardware emulation within a Kubernetes cluster. Another case that I've heard for multi-cluster is security boundary. An organization wants to manage their security boundaries by having separate clusters per group, or each group has different budget And so for cost reasons, it's much easier for them to have separate clusters. So there are a few cases where people are actually using multiple clusters. And in terms of actually using this to manage them, the hardware one is a little specific and unique.
I thought like if supporting the multiple team for the like multiple clusters, then yeah, the plan is for like managing the multi-cluster for each team. But I thought the multi-cluster is like we deploy a single service to the multiple cluster.
Correct. So if you have a centralized DevOps team, there may be like every team within your organization needs to use this application or something like that, where you're using the organizational boundaries to determine where you have clusters, but each of those organizations might need to deploy a centralized application for the larger company. Oh. So in those types of cases, I've seen them use this.
Oh, I see. Thank you so much.
Yeah.
Thanks for the presentation. I'd like to ask about the, let's say, about the work hub. The multiple.
That mic is having issues.
Is it? Is it possible to
You can talk and I'll try to repeat.
after having, how to say, without any downtime, do we need brand new cluster?
Is it possible to spin up new clusters within the multi-cluster environment without having downtime or to remove a cluster? It requires forethought. There was a talk yesterday by Ishii-san and another engineer from Google, and they were talking about considerations for doing cluster upgrades, considerations for the cluster control plane as well as for the node pools. And so a lot of those same concepts apply here, is you need to drain the cluster before you're performing an upgrade. I have heard a lot of customers say, like, I want to be able to do rolling upgrades for my multiple clusters the same way that I can do rolling upgrades for my workloads in Kubernetes. And I would say that the API implementations as they are now are not really there yet for doing a smooth rollout. You still have to do a lot of those considerations manually.
Got it. Thank you.
Thank you for your presentation. My simple question is, what is the functional difference between your solutions and ACM, Advanced Cluster Management for Kubernetes by Red Hat or Open Cluster Management?
So what are the differences between the solution that we talked about here versus what were some of the other examples?
Yes.
What were the other examples you mentioned?
Such as your solution and ACM can manage multi-clusters and deploy to cluster A or cluster B or migrate from cluster A to cluster B. What are your solutions, different points?
So I'm not sure exactly which other solutions you mean, but we did talk about several others in the talk, and a lot of them have very similar roots, like we were talking about. A lot of them kind of implement a list of clusters and kind of work with them from there, but they each work with them from their own particular perspective. The idea of these unified APIs from open source is that the vendors who run the infrastructure that you're running all of your clusters on will implement the best way to manage that infrastructure that underlies it. So I think the key difference in this or any other implementation is going to be, what perspective is that implementation coming from? Is it coming from the perspective of like a CD tool where they're trying to help you continuously deploy workloads to your clusters, or is it coming from a vendor who is trying to help you manage the underlying infrastructure? And so the implementations, I think, will differ depending on where they're coming from.
Okay. Thank you.
And we are basically at time, but there's one more I think we can do. Yep.
Sorry, thank you. And sorry, this could be the duplicated question previously mentioned, but if I understand correctly, this focusing on mainly on the control plane, but what about the data plane, like synchronizing the zone data of the Kubernetes between the cluster or global server load balancing is in the scope of other things or completely out of scope?
So the question is about kubedns and kind of the networking of the workloads within the multi-cluster environment, right?
Yep.
And that's one place where the vendor implementations of these standards really comes in. Like we saw in the multi-cluster orchestrator example that I showed here, we use a multi-cluster gateway, which is a concept within Google Cloud for our load balancer. And so it's going to depend on the environment that you're working within, how those get implemented. So the general use cases and concepts will be implemented in the standards, but the specifics will be implemented per vendor.
Got it. Thank you so much.
Yeah. Thank you so much for coming. ありがとうございました。